Hey everyone. Okay, so welcome to this crazy experiment that I'm doing. My first thing that I'm going to say is that I have no idea what I'm doing. So I'm just gonna put that straight up. I am literally this dog, or all the various dogs that came up in my search. I'm all of these dogs. Um, so this is very much how I feel right now. Because I've not really tried to do this kind of streaming thing, except in small cases. So we'll see how this works. I also don't have a super solid plan for the thing that I'm building. A lot of this is like I have an understanding of what it looks like in my head, but it's not like a class that I'm teaching where I have pre planned some series of steps. So it's very likely that there will be missteps along the way and so on. My goal is to show um, my goal is to sort of demystify programming in some way. I think I think in a class environment, I will stand up here in front of a whiteboard and I will say, "This is how X works, and this is when you should use it, and now you guys go home and practice it yourself." But you don't really see things within the context of a larger engine or within the context of a larger project, and that can be really important. And some of the classes that I teach and that we teach at the Academy of Art, we try very hard to at least simulate some of that. The AAA game architecture class, for instance, does try in terms of dissecting Unreal, but a lot of times you're just sort of dissecting what that is. You're not going through the actual design process and implementation process. And that's my goal. Um, this is in the context of a project that I hope to ship someday. So this is also not me just saying, let me throw some stuff out there. My goal with this is to actually and finally ship something internally. So first, what I'm going to do is I'm going to talk a little bit about the constraints and some of the things that I'm trying to do. So I wonder if I can open multiples of these. Cool, I can. So some of my requirements in my own life and just in what I'm trying to build here. The first sort of constraint that I'm going to say is that it's going to use what's called, or what I've called, the Bleach engine. So the Bleach engine is my own engine. I built it from scratch for the most part. It uses under the covers currently SFML for rendering and for OS abstraction, which is a more object-oriented version of SDL. So we won't really be looking at that in too deep of detail, but it is my own engine. So it's going to have its own idiosyncrasies and its own limitations and its own benefits. Um, Primarily, we're going to be writing stuff in C++ and Lua. We might do a little C sharp or Python. I don't know. Um, C sharp here I will generally use for tools. I should say visual tools. Whereas Python is more for command line stuff. And I already have some tools, like build tools and things like that, that I've written in these languages. The core engine is in C++, and then the gameplay scripting and a lot of the data is in Lua, which is interesting because there is no XML or like JSON or any of these other formats that maybe you've learned about quite a bit or that you've used before. That's one of the weird quirks of my engine it was an experiment that I tried that I've ended up really liking, is that all of my data files are in Lua. So all of my object definitions and so on, all that stuff lives in Lua. Um, these are kind of my major constraints here. I'll talk about the game design a little bit. So this is the game itself. I'll just run it. We'll see what happens. I don't know what kind of quality I'm gonna get streaming this. So I pull this over here to my secondary monitor by default, but I'll just move this over here. This is kind of what you get right now. Very programmer art, so enjoy. And then this is a console. The console is really cool because I can basically type whatever I want here. I can say x equals 10, and I can now print X, and so on. So this is just a cool little console that I built, which just pipes into the Lua interpreter. Okay, so the basic idea is that it is a Starship simulation. I'll zoom out a little. So think FTL, but deeper on the simulation. So I expect to have, this itself would probably be a relatively small ship. So I expect to have a deep simulation. Amusing to the Star Trek conversation I just had on Discord. You can think of it like a procedurally generated Star Trek in a way. You are the captain of a ship, and your goal is to try and go on missions and things like that. The universe around you is also generated, but more interestingly than that, I think, and what's somewhat different about this, is that my hope is that a lot of the story and interactions and things will be generated as well. I have some prototypes that I've built that try and mimic, or try and in some way model personality. So probably I'm not going to talk about all of that stuff today. Today my goal is to just get people in the world, which is not going to happen in an hour or in the 45 minutes that I have left, but I can talk about what some of my plans are for this, and then moving forward we'll dig into more of that stuff. Now, the very first thing that I do when I'm trying to build some relatively large system, like an AI system for instance, is I go to a whiteboard or one of these types of things. It's like virtual blackboard. And so this is just Mischief. I'm sure many of you have seen this before. I've already drawn out a bunch of stuff. I mean, if I zoom out, I mean, you can see a bunch of stuff. So I'm just going to kind of walk through some of these things that I've built and just kind of go through, like, what am I talking about? And I think it will be easier for me to do this if I just restart. So I'm going to leave this guy here, and now we're going to talk about the basic idea of AI. So what I want, and I've taken a little screenshot here. This is a sort of earlier version of the ship, but it's the same basic idea. I'll kill some of these layers. So what I have is these are the sort of characters. I've just drawn these little pawns. Red is for tactical, green is for like scientific. I may merge those, I haven't decided. The yellow is for navigation, this purple one is for you as the captain, this blue is for engineering, and white is for medical. So what I kind of want to do is I want to be able to have them have some sort of schedule. If I go back to the game, there's a very, very rough sort of UI in this little schedules thing. I don't have any people in this world. So if I go back here to the override and I load my older test ship, this will have some people in it. There we go. So I have these people here on the left, and I can say Delilah is going to be on this shift, and Liliana is going to be on this shift. And, right now they're all sort of stacking, and I don't have it set up, and it's literally like the shower icon sort of tiled. So this is all very, very temporary. But my point is that I will eventually have this sort of, multi-shift schedule thing going on here. A lot of the work that went into this particular window, the vast majority of it, by the way, was just getting things like scroll bars working. That in itself is its own special challenge. So, and it looks like my camera still decides that it wants to move even when there's UI up. All right. So that's kind of what I'm going for. So I'm going to reset this world thing so that it goes back to my old world. So that's the idea. That's kind of what we want to do. So my engine has a component architecture just like many other games. So basically, whatever it is, it's going to have some crew AI component. So this is the component that's basically going to manage all of the crew stuff. all of the AI for the crew. This is probably going to be a C++ component, almost certainly. Mostly for performance reasons, because I think, I could be wrong, but I think a lot of stuff is going to happen here, or at the very least, it's going to be a lot of data that C++ needs to care about. My goal, I don't know how achievable this is going to be based on my min spec, but my goal is to have something like 1,000 agents all doing their thing, all pathfinding and going to their various stations and working and all of that stuff. So 1,000 agents. So holy shit, we need to scale this thing. So anyway, there'll be some kind of crew component thing. My current thought, and I'm just going to kind of half-ass this a little bit. My current thought is that I'm going to have a bunch of like what I call pass-through functions. So this is going to be the core interface to the rest of the game and the rest of the engine. You'll find an entity, you'll grab its AI component, and you'll call some function on it, which in turn will delegate that call to some other system. So the whole point of this is that this guy is now very isolated. And the really cool thing is that means that anything that this guy connects to can change pretty trivially, because I basically, I'll move over here. I basically have game in its own little world, and I have this AI component in its own little world, and game talks to AI, who in turn talks to, you know, who knows what else this guy's going to talk to, and then these guys are going to do. Like, these guys are all, you know, somewhat dependent on each other. So the thing is that now all of this stuff can change independently of the game, and the game can change and all this stuff. So this guy becomes my interface. That's the plan, you know. I think it was Sun Tzu. I forget who it was. I think it was Sun Tzu who says, "No plan survives the test of the enemy." So, you know, we'll see. We'll see if this happens. Okay, so moving on. I'm gonna kill this thing. If I was smart, I would have put this on another layer. Because now what we need to do is we need to define some of the other things. So I think what makes sense is these are officers and crew members aboard a starship in the military. And any of you who have ever been in the military will know that the military thrives on things like routine. You have a schedule. This is when your watch is. This is when you need to be at this particular place. And probably you need to be there 15 minutes early. So, I'm going to pull this guy down a little bit. Great. And let's build another thing. So, there's going to be 1,000 of these, or a bunch of these. The way that my components work, if I actually show entity component.h, you'll notice something that is sort of missing in here. And one of the things that's missing is an update function. So in Unity and Unreal, you know, Unreal has tick, Unity has update. A lot of, you know, engines that are out there, each component has some update function. I don't do that. I think a lot of components, that's wasted, and you just don't need it. It's also somewhat inefficient because you're, through things like, you know, without getting into huge amounts of detail, it can be a performance issue from things like CPU cache, right? If I have a big array or map of every game object, and then I go for each game object, then I have to dig into some other map to find some other pointer, which I then have to dereference, and then I can finally call update on each of the different components in there. It can get slow. Not a huge deal, but if I'm trying to deal with a whole bunch of entities, that's going to get slow. So my plan is to have my plan is to have an AI basically component system. And this is how my engine is set up. It's set up so that if you want to iterate over, a whole bunch of game objects or a whole bunch of, usually it's components that you care about, then you do it through this concept of a system. If I were to give you an example, this is the sprite render system, which has an array of every object I'm trying to render. And so in here, it does get an update, and this gets called every frame. And so in here, it's going to call the magical add object to scene function. I feel like I can expand this a little bit. There we go. Yeah, so this says, hey, if you have render data, then you're allowed to call this add object to scene, and then that's going to add the object to the scene. And so I'm going to do something similar here. So I think what I'm going to do is I'm going to create some kind of, my current plan is an update queue of some kind. Queue is nice because I can time slice it, or some kind of update thing. It may not be an actual queue. Obviously, this is going to have some kind of update function, which is its sort of virtual function. And then there's going to be a bunch of events, I think, that this is going to respond to. That seems dirty on XXX event, but that's fine. Let's see. So yeah, that's kind of what I'm thinking. And then there's the actual, what I'm going to call the agent. So the crew agent is the actual AI data and piece and all that stuff. So if you think about it, this has like the instance data. I don't know what it's all going to be yet. Anything that the AI needs to care about, I think. That's probably true. For example, if I'm doing a schedule, what is my current schedule task? In fact, I'll write that specifically. There'll be a schedule. State, like what state am I in? Just things like that, right? Just all this crap. I don't know if there are going to be functions. This may be pure data. I haven't decided yet. We'll see when we get in there. But this is going to be the actual data itself. And then here's kind of the magic. This is a filled in little diamond. And I'll have some number of these n. And so what the filled in diamond means, of course, is that it's going to own it. It's going to own objects of it. So this whole relationship might look like, I use EASTL, so that's why you're going to see that rather than STD. So I might have vector crew agent, Q or whatever. So notice no pointer, no reference. So the reason why I'm doing that is mostly I want to vectorize those operations. I want as much as I can to be able to have the data all live together in memory, because that's going to be a lot faster. And in fact, what I may do is I may split up this agent into several different structures so that I basically have a struct of arrays sort of feel, like the things that are all together I'm iterating over together. But that's all stuff I'll care about later. I'm going to zoom out slightly. Actually, if I do that, it's going to break something, so let's not do that. Reset, there you are. Okay, so on top of all this, the component is going to know about, is going to know about this guy. He's going to maintain some reference or something so that we can get this. The pass-through functions will basically call things here, possibly here, but basically call things here. So these events we should talk about briefly. So this is going to be like uh, gameplay events. For example, like, say, losing oxygen. That's an example of a gameplay event. So a gameplay event like losing oxygen or whatever. So my basic plan, and I'll go through how all of these systems kind of work. My basic plan is to have the AI make a decision of some kind, and then I don't have to care about it. I'm not running AI every frame. I think that's a pit that people fall into to start, is they run AI basically every frame. And you don't want to do that except in very specific circumstances, I think. This is all probably C++ layer as well. For this next part, I feel like I'm not going to redraw all this stuff. So I'm going to just pull over my thing that I already drew. And we'll reset this guy. This is just the exact same thing that I drew. It's slightly smaller, I guess. So this, I don't know if you guys have ever seen this before. This is a sequence diagram, which is going to talk about how I can basically, how things flow. So these boxes here represent instances of things or objects in some way. So I just have like the engine is going to do stuff. So this is like the basic gameplay. And then the AI component is going to do stuff. The AI system is going to do stuff. And then the agent is going to do stuff. And this just walks through the flow of how that works. And I have 3 different things I care about: initialization, update, and event. So to walk through these, let's add another layer so I can draw on top of this stuff. Okay, so I'll zoom in just a little bit. Have I zoomed out? So let's do this, zoom into this guy. Okay, so initialization, how does this work? So the first thing that happens is the engine is going to spin up this AI component. So this comes from data. Oh, wow. That's not what I wanted. I wonder what's causing that. That's interesting. Sometimes Mischief will do this. Let me close this and then reopen it. Great. Awesome. Okay, so it's good now. So this is basically going to come from data. So somewhere in data, it's going to say, I need to load, these 20 objects. And so then it's going to spin up the game objects along with this guy. When an object is spun up, it's going to get some kind of initialization. So the component's going to be initialized. I capture this specifically because you'll note that the agent is not created this way. So then it's going to notify the AI system, which is spun up elsewhere. Hey, I've created this AI component. Do you care? And so in response to that event, it's going to say, great, I need to create an agent. So it's going to instantiate this agent, which is this guy here. Then it's going to set the agent and return. So this is just this is the sort of handshaking, like set everybody up. And then we're going to immediately add the agent to our queue. And so you remember our queue is this guy. So what that's going to do is the agent is going to get an update for the first frame, or the first set, basically. So as soon as the actual core main loop happens, then I'm going to have 100 agents or whatever, 1,000 agents all queued up in this queue that say, hey, you need to run AI. So they're all going to try and run AI at this point. This will probably end up changing depending on what I'm trying to do. So it may load or something like that. Alternatively, what I may do here, and this is what I've done in previous games, Sims Medieval I think did this, is instead of just saying, hey, add to the queue and hope that some good stuff happens, I will actually add to the queue and force simulate a frame while the loading screen is up. But you do it in a way so that none of the animations run, none of the pathfinding runs. You just teleport to the location, teleport into whatever posture animation you're trying to do. I'll probably end up doing this, but I'm going to start by just adding them to the queue because it's easier. Generally, I tend to start with what's easy and just get it going as long as I don't paint myself into a corner. So the update. So, things are initialized. Every frame, this is the update. So the first thing it's going to do is it's going to pop the first thing off the queue. If there's anything. If there's nothing, great, we're done. Then it's going to run the AI. FBA is shorthand. It stands for Find Best Action. This was an acronym we used all the time on The Sims, and it just sort of carried over. I use it sort of for everything now. But Find Best Action is like, do the AI, do the thing. And then that is, once that action has been done, that's going to push some action onto this guy, and then we're going to bail, and then we're going to time slice if necessary. So this is just for me to catch, hey, we're time slicing this queue. So what that means is, and that looks more like a stack. If this is my queue and I have these guys in the queue, what I'm going to do is I'm going to pull this guy off of the queue, run Find Best Action, and then I'm going to look at my clock. And if I'm past some allotted amount of time, like if I still have time left, I'll do the next one. But as soon as I run out of time, then I'm going to bail. And so the queue, I've lost these guys now, right? These guys are gone. So this is the new head of my queue. And so then the next frame, I'm going to start here. So that's why it's a queue. It's just a sort of rolling queue. That's the plan. That's how I think this will probably work. The advantage is that I spread out the AI among multiple frames. The disadvantage is that you can go into a well of despair. It certainly happened on The Sims quite a bit in the early days. But if I'm adding more things to the queue than I'm removing, then I'm screwed, and certain agents will never get their update. So that's not good. But we'll cross that bridge when we come to it. This is the basic update. Notice that in none of this am I running AI every frame. If this queue is empty, which I think it will be often, then no AI happens. So they'll run whatever action they're doing. Most of the time you can think of an action. This is kind of the Peter Russell, or Peter Norvig Stewart Russell. I miss those names. There's a book. If you've ever taken my AI class, you've heard of this book. It's called Artificial Intelligence, A Modern Approach. Yeah, here it is. Well, this is the cover for it. You can find it on Amazon. It is not for the faint of heart. So be warned. If I go backwards, let's see, Amazon is in here somewhere. There it is. Yeah, $100. Buy new, yeah, it's $100. That's about right. It's a pricey book. So this is like people who do this as their, like, this is not game AI, although they have a lot of chess pieces here. This is like academic hardcore AI. Grad students in computer science and AI will often use this book. And I use it for a few things. But if you're super serious about AI and you're a programmer, you pretty much have to have this book. It's one of the core tomes on AI in general. Okay. So very simply, the kind of the Norvig and Russell style of AI is, and if any of you happen to be in my AI class, this is a slight spoiler for this week because I'm literally talking about this exact thing, or at least this part of it. You have this thing called percepts. And so these in games, oh God, if there's artists watching this, I apologize. This is an I. There's, whatever. I'm going to stop trying to draw things. This is going poorly. All right. Percepts are any kind of sense that you have. In games, they're often, they can be the five senses. Sometimes we try and model the five senses. In robotics, there are often other things. I built a little robot, and it had two IR LEDs, which then had like IR sensors, and they sort of looked like little barrel things with a little thing like this. And there's one on this side. These were sort of the eyes. And then they had little whiskers that came out, which would short these little pins. So they were basically switches, and that's what I had. So percepts in chess, we don't bother modeling any of that stuff, right? In chess, we have perfect knowledge. So the percepts in a game like chess are game state. It's just literally the board. That's it. So, in here, we'll figure out what percepts we really want, but those percepts go into sort of the agent, and then that agent goes to the world. And I'm going to draw it in a different color. That looks like a box. The world feeds the percepts, of course. So you have this sort of cycle. And that's kind of the idea. And so these are actions. And then these are percepts, as I said. So I'm following a similar model. So from my perspective, if I'm going to step back over here, what I'm going to do is I'm going to have, I have the agent right here. I'm not going to draw in a box. So the agent is going to basically call find best action, which in turn is going to push some action onto the agent. Now an action, in its simplest thing, is run this animation at this location. I'm going to say with these effects. This is basically what an action is. There's other complications. How are actions quit? How do I bail from actions? What things can it affect? There's a bunch of other things. How do I choose where I go? But at the end of the day, it is run this animation at this location with these effects. And when I say effects, I don't mean like sparkly effects. I mean gameplay effects. Maybe I should say that. With these gameplay effects. So what does that mean? In simulation games are all about numbers. If you play SimCity or The Sims or City Skylines or any of these games, it's all about numbers. And that's what this is going to be about as well. So if I go back to my little thing here, if I have like a dude or a woman at these stations, it's going to have some overall effect on the power of the ship and what the ship can do. Maybe in order to fire weapons, I only need one person at tactical. But if I have all three of them at tactical, then my efficiency goes up. So in that case, if this guy is going to run it, and I have some of these in here, I think. What's this button? No. When they run their AI, they're going to try and go to the most obvious locations. So if I have all three of these people here at these stations, my efficiency is going to go up. So if we go back to my definition, run this animation at this location with these gameplay effects. Okay, so that means he must, a typical action says, for this, say, red guy here, or we'll say this green guy, why not, is route to this location right here. You probably can't see that, so what I'll do is I will press this button, which will create me a new layer. And I will do it in yellow. Okay. So we have this guy, and so he will go here to this location. This is sort of terrible. Let me use a better brush. He'll go here to this location. run an animation, which is like I'm going to sit here and type things on this system. And then the gameplay effect is that, say, sensors or whatever are improved. If it's break time, this guy, maybe I shouldn't use that. Like maybe this medic will go out here and run this animation on this food dispenser, get food, and then go over here and run an eat animation here, which will improve their food, their health, all that kind of stuff. That's the idea. That's kind of what I'm going for. So this is just a view of what happens when the AI first runs. Everyone does their thing, and we'll talk about that in a minute. Okay, so run this animation at this location at this thing. So that's what an action basically is, if you really break it down. And a lot of programming is taking a design, which is we want a bunch of people on the ship acting like people on a ship. A lot of programming is breaking that down. Okay, what does that really mean? Well, it really means at the end of the day, we're running some animation at some location with some extra effects. And so we build a system that does that. I have already done that. I've built what I call the action system, and I've used it on various projects. So this system exists for me, but it's a system you'd have to build. Okay. So that's kind of the update. There's also events. So that's the last thing I'm going to talk about in this sort of world here. There's these events that can fire. So before I get into these, let me talk about this sort of stuff over here. So I've been trying to think about how do I really want to make this work. I'm going to make this go away so that all those go away and do another one. And so there's a lot of different things. And so basically we've been talking about crew AI, which is this stuff down here, which I'm going to do in some color I'm not using. I'm using all of them, so I'll use this. About the crew, which is this stuff. So that's great, but we need something that manages it. So I've come up with this sort of crew director. And the idea is the player, you like my little face here? The player will directly interact with the crew director. So the player, that's the actions the player can do. So unlike your typical RTS, you do not have control over every character. You have direct control over your captain, but no one else. You have to give orders to other people in other departments, which means a big question is where do you place yourself and how much do you trust your crew and so on. So you will give an action. You will say, I want emergency power. And then that will trickle down here and say, cool, the captain has said emergency power. I'm going to assign these 2 crew members to go to, these stations, these like engineering stations, and give, this guy will go to like maybe this like warp nacelle or something, and we'll give emergency power. So that's the idea of how all of this stuff I'm hoping will work, like this path will work. Barring any particular thing, they're going to be generally running their schedule. So you can see the ordering up here. You can see the ordering up here. So these are weights. So at a weight of 1, they will generally be running their schedule. And that schedule will be defined however you want it defined, but there'll be a default. And so the schedule will just keep the ship going. If you explicitly ask for something, then that will have a higher priority, and they will then do the thing that you asked them to do. And again, that's like larger commands, like target this ship. I want to jump for this location, and so on. And then at the highest priority, they will save themselves or others. This is the like emergency priority. That's my thought. So if I go back to my thing here, and here's my emergency thing, there's some explosion that happens. Let me remove this. So let's say some explosion happens. So you might have these guys. Remember, they've all gone. Let me start over. Okay, so everyone maybe starts here. At the lowest priority, some schedule thing happens. So they all go to these locations. So now they're all at their spot. This purple guy is the player, so I didn't move him. So these guys are all at their stations, basically. Then some emergency happens. So I'm going to move this so that, so the emergency happens. Remember, these guys are at their location, so I'm going to remove these so it's less noisy. So what happens is a big hole is here, and this purple guy, the green guy who went here, this purple line represents someone whose morale just broke. So he's like, I'm going to save myself. I'm out. I'm going to get out of here. The other green guy who was already at this location is maybe dead or something bad happened. The captain then says, I need you to repair this thing. And so then this dude, like the scheduler, this guy here, this crew director says, you know, let me add a new layer. Says, this guy is busy. Like, this guy is super important to the running of the engine room. So I'm going to send this guy, who's maybe better at repair something. So this guy comes over here and starts trying to repair stuff. That's the basic flow that I'm expecting. That's what I'm hoping is going to happen. So, we'll see as we dig into it. So that's the idea. And then you can kind of see what happens here as I go through some of these things. We have the player can make some action, which will do some order. But then, like, some bullshit can happen. And that event will happen. And then maybe this guy says, this guy, nopes right out of there. So that's the idea. When I thought about these different high-level states, I realized that what I'm really talking about is a state machine, which is what I have up here. So a state machine is going to be trivial. There's going to be, I didn't add the third one, but there's going to basically be 3 states probably. Run your schedule, emergency, or something else. Perform order. I may just have it as a hierarchical series of weights. I haven't decided yet. So that's the next thing to figure out, is how's all this gonna kind of fit together. So that's the plan. Here's how the events work. We have, there's no, we've lost oxygen in a container, in a place. No O2 event. So that gets sent, and you can kind of remember from here, the engine sends that to the AI component. It says, hey, this agent no longer has air, or its air is leaving. So that goes immediately to the agent. The agent sets, hey, I should probably save myself. It will then enqueue himself into the queue, basically, and says, hey, probably something changed. I'm going to enqueue myself. It seems bad. And so then this will happen, right? Because now he's added to the queue. So this thing that's going on every frame, up here, will happen. And so then off they go. One of the interesting things about this is that an agent is always performing some action. Almost always performing some action. So one of the cool things is that we'll let it trail. I'll show that in a minute. So we'll have, actually I'll show it now. So we might have this agent here, and he's doing something. These are hands. Just enjoy. He's doing something here. And so I'll come to some point and I'll say, hey, I need to do something new. He'll still be doing this for maybe an extra few frames while this queue sorts itself out, and then he'll bail and do something else. This is what we did on The Sims. So a sim might already be in queue to make another decision, but they'll sit there and keep doing the same thing until it's time to go. That way you don't have this I'm going to do this thing, then stop, then wait for 100 milliseconds, then I'm going to do something else, because that seems artificial. We'll see if that happens. I'm not super convinced that I'm going to actually do that. We'll see. But that's kind of the plan. So this is how I think this is going to work. My engineering sense is tingling and says, if I'm going to do this sort of emergency thing, this enqueue right here, I might want to make this, let's use my thinner thing. I might want to make this a priority queue. I don't know. 3 question marks. I don't know. We'll see if priorities are necessary. Okay. That's kind of it. So that's the plan. If I zoom this out, you can kind of see everything going on. That's the basic idea of what I think I want to do. Most of the time, they'll be running their schedule. The player can tweak that. I think I'm going to delete this layer. I think one takeaway here is that the crew director is going to be the one doing like the high level AI for the most part. These guys, I think, are going to be a little, I don't know, simpler. I think they're mostly going to be like, I'm going to route to a place and do a thing, and they're going to mostly have data. I think the crew director is where the complexity is mostly going to be. That's what I'm thinking right now. That's my guess. It's like, because the crew director is going to be like, how do I make this look good? And then obviously the disasters are going to come and break everything. So that's the plan. All right. This is very much how I think about things like AI. This took me longer to come up with than what I just, spouted out, because I know what I'm doing here. There are many different iterations of me, like erasing pieces and all of that kind of stuff. But for the most part, this is how I approach things. If I go back to my little diagram here, this is the same thing. Like, I started with a screenshot of the game, and then I added, how do I want schedules to kind of work a little bit? And I was sort of talking to myself while I did this. I added the emergency stuff. I don't know what this UI stuff is. I don't actually remember what I did here. Oh, I started to do stuff. Yeah, and then here's where you can see replan, repair, schedule. This is just a legend of the emergency stuff that I did. So yeah, this guy did live. Oh, that's right, replan. So this guy lived, but this thing is broken, so he was forced to replan and move to this station. His morale didn't break. His morale was totally cool. So that's kind of the idea. Okay. If there are any questions about how this works or how I'm planning on kind of setting this stuff up, we didn't look at code at all today. I think this design took me. I can actually look at my little schedule. I have a little timesheet. I think this plan took me half a day to come up with. So, I've done no code. I mean, if I scroll down here to my entity components, I do have like a Lua version of some of this stuff, but it's mostly like data. If I get out of the data stuff and look at the C++ level things. So I do have some schedule stuff. The schedule system is a whole other can of worms. And I've started to like sketch out some of this stuff and like what does an AI state look like and like the state machine, but there's really nothing here. So I'm starting pretty fresh with this stuff. Yeah. If I go to my processes, yeah, I don't have it at all yet. And then if I go to the object system, I do have the process. That's right. I thought I did. Yeah. I mean, I have this, which right now is just my agent list, which is just a vector of agent pointers right now. This is probably going to change. I might have two different lists. I don't know yet. So this is all stuff that I have to think about and figure out. I don't have much except some of a little bit of the time slicing stuff. So there's very little actual code here. One thing that I will mention is that while I will probably talk about how, like, some of the basics of the schedule system, I'm not going to go in these videos probably into detail on how the schedule system works. And the reason why is if you search for Game AI Pro, I wrote an article in Game AI Pro 1, which is available for free now. Game AI Pro is really cool. We worked out a thing with the publisher where I think it's after 4 years. You can get it we can post them for free. So they're all posted here for free for Game AI Pro 1, which I have 2 articles in, and Game AI Pro 2, which I don't have anything in. And Game AI Pro 3 is out now, but it's not open. I have 1 article in this somewhere. And then Game AI Pro 4 is happening, which I have 1 article in. The deadline, I just submitted my white paper, so I don't know when that's actually happening. I don't know where it is. What? Nothing? I don't remember what my own article is called. Here it is. Breathe life into your background characters. And I have some demo code. So this is the article. If you want to know how I plan on doing scheduling or how I've basically done scheduling, read this article. I'm literally going to do it, some version of this. I'm taking this core idea. This is taken from The Sims Medieval for the most part. It's similar to what we built there. I closed the wrong thing. Reopen. And there's demo code, which runs. I think I might have built this in Visual Studio 2012. So you might have to like dick around with it a little bit to get it to work, but it should be fine for the most part. It should be okay. So if you want to know how the scheduling system works, read that article. There will be updates and tweaks and things like that as I make changes. Nothing is ever perfect. Okay, so that's it. That's kind of what I think I have time for today. It's 5 and I have something that I have to go do at 5. So we'll end here. I'm going to give a little bit of thought to how I want to start the actual code process. If you're curious what I'm thinking about doing, I'm going to look at... Oh, this is the big one. I'm going to kill this one. Go away. I'm going to look at this, and I'm probably going to take this piece here and break it down even further. Because now I kind of understand how things talk to each other. I kind of understand how things are going. I'm going to probably fill out the crew director a little more and think about, like, what are some things that we can really do? I think my next step is kind of the player story type thing. Like, that's sort of what I was trying to do here. Like, some shit went down. Like, how do we make that work? And then eventually the real goal is to be able to run this and be here in this ship and have people running around doing stuff in each of these different locations. And I've actually spent some time figuring out like what I want these locations to be. This is the bridge. This is the hyperdrive unit. These are crew quarters. These are officer quarters, which are very different. I have 2 weapon systems here and here. Up here is science and basically sensors. There's a medical bay down here. There's engineering are these 2 sections, this guy, and then this guy and this guy are basically the engines. You can see my amazingly drawn engines here. I think I'm going to go into art because damn, look at these. And then this is meant to be like the power plant. And I don't know what kind of ratio these are going to be. Oh, and this is the mess. So the gameplay idea is that you will basically drop and stamp out these rooms, and that's how you build your ship. So you build ships by dropping rooms and things. That's very intentional if you're curious about some of the design. Games like Minecraft, if you just look at some of these images, like, to me, this is way, way, way too granular. For me personally. That's why I don't like Minecraft, because it's just too, like, I'm dealing with blocks. What's the other rule? There's, I want to say it's Starbound. I might have lied. No, it's Starbound. Yeah, like this, super cool, but it's like, oh my god, I have to place every single block of wood. Like, nobody has time for that. So I hate those types of games. They're just too granular for me, even though I love the idea of this game. There's a really great game that Dan showed me, which I really have come to just love. It just actually, in January, it just ended its early access. And so I highly recommend that you go and play this game. It's open world, it's beautiful, it is stunningly done in Unity, which blows me away. Although you can see where there are a lot of concessions they had to make, but it's gorgeous. Here is some, that just looks like concept art. In Subnautica, the base design, I'm kind of going more based on this stuff, even though my game is 2D. Where you have, like, okay, here's one. This circular room is what's called a multi-purpose room. And the majority of what you're laying down is multi-purpose rooms plus, like, hallways. And so here's another base, which has, you can see a few of them here. This one just has glass windows in it, but, you know, it's the same thing. So most of the rooms that you lay out are these multi-purpose rooms, and then whatever you put in them is up to you. It doesn't matter. And, like, the purpose of the room changes based on what you put in it. So, like, you could put in a reactor, and now it becomes your engine room. And so I'm doing something kind of like that. There was a demo that I played from a colleague of mine that I worked with on RimWorld, where he would, like, you would build out sort of piece by piece, similar to RimWorld. It's the same sort of build style. the room, and then you would place the purpose of the room, and that just didn't feel good at all. So instead, I think just stamping out the rooms in general. So anyway, that's kind of what I wanted to go over. My plan is to do this, 2 or 3 times a week, probably on Wednesday, Thursday, Fridays. So thanks for watching. Think about what you want from this sort of thing. I think my main ideas are I can basically stream a workday, which seems long because that's 8 to 10 hours. Another option is I can do a workday and then have like an hour-long summary of here's all the shit that I did. Those are the two main ways that I think this can work. So think about it. Let me know. I see there are 5 people watching, which is 5 times as many as I thought. So great. Yeah, just think about what you want from this and what I can do. So that's it. Again, thanks for watching, and I will see you guys around.